Hello, Flat Earth researchers, debaters and debunkers. One of the first things a truth seeker might well do when they hear about the Flat Earth is to go back and look at the history and so-called science that has built the heliocentric globe Earth model over the past 500 years or so. The history books tell us that the calculations and measurements done to establish the size of the spherical Earth were first done by Eratosthenes and followed by others who looked at the sun and stars as ways of making those measurements rather than actually finding or measuring any actual curvature upon the surface of the Earth. We are told that the Greek scientist Eratosthenes was one of the first people to measure the distance to the sun from the Earth, as well as establishing the size of the spherical Earth about 2,000 years ago by measuring the differences between the angles of shadows cast in two different places about 800 kilometers apart in Egypt. But a little experimentation can lead us to find that you can achieve the same effects with a very local sun moving over a flat plane. Then we have accounts of Giovanni Cassini, who was an Italian mathematician, astrologer, and later astronomer and engineer who was alive between the 16 and 1700s. He is credited with various observations of celestial objects. He was a geocentrist, but later changed his mind to become a heliocentrist. It says here that he was attracted to the heavens in his youth. His first interest was in astrology. While young, he read widely on the subject of astrology and soon was very knowledgeable about it. This extensive knowledge of astrology led to his first appointment as an astronomer. Later in life, he focused almost exclusively on astronomy and all but denounced astrology as he became increasingly involved in the scientific revolution. Cassini is said to have measured the differences in the size of the sun throughout the year by projecting an image of the sun onto a church floor, and this allowed him to measure the change in diameter of the sun's disk over the year as the Earth moved towards and then away from the sun. Well, at the time he was a geocentrist, but he apparently concluded that the changes in size he measured were consistent with Johann Kepler's 1609 heliocentric theory, where the Earth was moving around the sun in an elliptical orbit instead of the Ptolemaic system, where the sun orbited the Earth in an eccentric orbit. But this changing of the size of the sun for the observer in a particular location can also fit with the flat Earth model, with the sun doing concentric circles above the flat Earth and going higher and lower in the sky at different times of year to create the seasons. So while there appear to be very solid and consistent accounts of these heroes of science throughout history and the discoveries and theories and beliefs that they held, we do also know that history can become very clouded for political or other reasons and can even be rewritten by the people who have a certain agenda. While we do not even know if these people existed at all, we certainly do not know what beliefs they actually held at the time of their discoveries and whether they were swayed or influenced by certain people or trends at the time, and whether their words and theories have been changed or manipulated in any way since they died. So while the scientific method is championed, applauded, and even demanded by truth seekers, it is easy to see how certain ideas, beliefs, and ideals can have been perpetuated throughout the ages and their stories told so often that they appear to become just a fact of life. But any truth seeker who dares to question this will be met with the wrath of globe Earth defenders who will verbally abuse anyone who dares question these historical accounts. But if we just look at the debate that has been raging for decades about the speed of light, for example, which is an integral part of the heliocentric model, we can see that it's been very difficult to reach any kind of common consensus or agreement among the professionals and institutions involved in defining where we live. This article on nature.com, which was published in September 2012, gives us an insight into some of the debates and infighting that has gone on to define things like the distance from the Earth to the Sun, bearing in mind that the heliocentric model and Newton's theories say that the Sun and the Earth and the other celestial bodies have certain masses and sizes and distances from the Sun, which causes them and their gravitational fields to remain at certain distances apart while they spin around each other. But here we have a slightly different explanation of how this distance is being measured. The astronomical unit gets fixed. Earth-Sun distance changes from slippery equation to single number. So this is something that has been calculated out of convenience, not necessarily measured. But let's have a look. Without fanfare, astronomers have redefined one of the most important distances in the solar system, the astronomical unit, AU. The rough distance from the Earth to the Sun has been transformed from a confusing calculation into a single number. The new standard, adopted in August by unanimous vote at the International Astronomical Union's meeting in Beijing, China, is now 149,597,870,700 meters, no more, no less. It goes on to say that the distance between the Earth and the Sun is one of the most long-standing values in astronomy. The first precise measurement was made in 1672 by famed astronomer Giovanni Cassini, who observed Mars from Paris, France, while his colleague Jean Richer observed the planet from French Guiana in South America. Taking the parallax or angular difference between the two observations, the astronomers calculated the difference from Earth to Mars and used that to find the distance from the Earth to the Sun. Their answer was 140 million kilometers, not far off from today's value. Now, of course, it is assumed that these people were using the geometry prescribed to them and probably weren't taking into account the idea of perspective, giving us different views of the same celestial object from different locations on the Earth. If you consider it as a point of view of perspective, then you'll understand that a star or wandering star or planet close to the horizon is considered far away, and one that is high above the horizon is much closer to that observer, which is presumably what these gentlemen observed, but they were not considering it as being something to do with perspective. So, until the last half of the 20th century, such parallax measurements were the only reliable way to derive distances in the solar system, and so the AU continued to be expressed as a combination of fundamental constants that could transform angular measurements into distance. Most recently, the AU was defined as, take a deep breath, the radius of an unperturbed circular Newtonian orbit about the Sun of a particle having infinitesimal mass, moving with a mean motion of 0.01720 blah 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 radians per day, known as the Gaussian constant. The definition cheered fans of German mathematician Carl Friedrich Gauss, whose constant sits at the heart of the whole affair, but it caused trouble for astronomers. For one thing, it left introductory astronomy students completely baffled, says Sergei Kleoner, an astronomer at the Technical University of Dresden in Germany. But, more importantly, the old definition clashed with Einstein's general theory of relativity. As its name implies, general relativity makes space-time relative depending on where an observer is located. The AU, as formally defined, changes as well. It's shifted by 1,000 meters or more between Earth's reference frame and that of Jupiter's, according to Kleoner. That shift did not affect spacecraft, which measure distance directly, but it has been a pain for planetary scientists working on solar system models. The Sun posed another problem. The Gaussian constant is based on solar mass, so the AU was inextricably tied to the mass of the Sun. But the Sun is losing mass as it radiates energy, and this was causing the AU to change slowly as well. The revised definition wipes away the problems of the old AU. A fixed distance has nothing to do with the Sun's mass. And the meter is defined as the distance travelled by light in a vacuum in 1/299,792,458 of a second. Because the speed of light is constant in all reference frames, the AU will no longer change depending on an observer's location in the solar system. Redefining the AU has been possible for decades. Modern astronomers can use spacecraft, radars, and lasers to make direct measurements of distance, but some of them thought it was a little bit dangerous to change something, says Nicole Capitaine, an astronomer at the Paris Observatory in France. Some feared the change might disrupt their computer programs. Others held a sentimental attachment to the old standard. But after years of lobbying by Capitaine, Kleoner and others, the revised unit has finally been adopted. Capitaine and Kleoner said that the streamlined AU is already having a positive impact on their lives. Lobbying for change has been time-consuming, Capitaine says. I will have more time to devote to my research. I'm happy that I don't have to explain it to my students any longer, adds Kleoner. The new definition is much easier to understand now for everybody. So we see here how we have a marriage of convenience with the mathematics to help us more standardize our heliocentric model. But it's all based on the assumptions that the Earth is a ball and spinning round the Sun without any scientific proof or any taking into account of perspective. So the message here to anti-flat earthers rushing to defend their heliocentric heroes and models is that no, the truth seeker is not feeling superior or more knowledgeable or more intelligent than all the scientists that have devoted their time, efforts and energy to literally shaping our world. It is just an understanding that while we can demand the scientific method and try our best to stick to it, we cannot avoid the fact that scientists are only human, just like you and I. Thank you very much.